What is a PLC? A PLC is a programmable logic controller. More specifically, a PLC is an embedded industrial computer that is designed to operate over long periods of time in extremely harsh conditions. At its heart, a PLC is a computer that has its inputs and outputs beefed up so it can handle higher voltages than a normal consumer-grade computer. A PLC normally has many more inputs and outputs as well. A PLC will take a look at what's on the inputs, use that information to make decisions based on its programming, and then change any outputs that may need to be changed based on these decisions. The program is the logic part of the programmable logic controller. I've heard it said before that logic is the art of reason, and I really like how poetic that is. When we program anything, there are two main parts, logic and syntax. Syntax is how you convey to something that you what you want it to do. It can be through language or symbols. While there are hundreds of ways that you can write syntax, be it through high-level programming language that are a lot like the languages we use to communicate with each other, opcode that uses just a few letters, like let's say JNZ for jump if it's not zero. That represents raw binary code, just ones and zeros. Or something that, like we'll use in here, called ladder logic. That is, we're able to lay everything out visually, and for one thing's for certain, even if we have 100 ways of writing syntax, is that logic transcends them all. Okay, you're strong at logic, you're going to be a good programmer. Okay. Logic basically breaks down a problem until it can be answered with a collection of just yes or no questions. If you can get to this level, you can have millions of tiny little switches answering those questions for you. And then you have a computer. If you can get strong at logic, it will not matter what language is being used. You can easily adapt it to any of them. Logic is the problem-solving component of that. And it's probably the most important thing that you'll learn while you're in this program. What does a PLC look like? Okay, so got some pictures. All right, so we got a lot of different brands. In America, you'll see a lot of Allen Bradley. There's Koyo, Omron, Delta V. Delta. Right here, I have some pictures of Allen Bradley Micro, an Omron compact, a Siemens logo, a Delta standard, and a Koyo brick. Now, this is what's called fixed. All right, that means that there's a fixed number of inputs and outputs, and they're all centrally located. Okay, those are good if you've got a machine that can all be connected at the same point. Okay. We also have things like bricks, but you can add on to them, which are modular. So you'll have a primary processor, and then let's say you needed a whole bunch of inputs but not a whole bunch of outputs. Instead of buying a really big PLC that had 50-50, you could buy a modular setup so that you could add on whatever component you needed. Let's say that I needed analog inputs, need a bunch of analog inputs. I would take that first processor and then I would put modules on the end of it to add whatever components I needed. So it's a flexible way of not wasting your money. If you don't need 50 digital outputs, then you don't have to pay for them. Okay. So here's a picture of, I said modular, but more expansion. On the next one, it's modular. So we can expand that processor up. Now, you see they're going to the side of it, and there's not a physical limitation on how many modules you can use. It's usually just a logical one. Where with the modular, you have, what we call a backplane. And so you'll have a power supply, and right beside the power supply, you'll have a processor, and then you'll have a set number of spaces that you could fill with different cards. And it works the same way as the expansion does, but it kind of limits you on how many, because that backplane is a certain size. Okay, so if you look, they're all kind of contained. Okay, and then you have distributed, which is where let's say you don't have one machine, you have a few machines, and you need them to work in tandem. Well, there's no sense in running 30 yards of wire from a button way over here if you've got, a whole lot of inputs in this particular spot. So you just imagine those bricks. Let's say that we put a brick over here that, or just a contained unit that takes a whole bunch of inputs, because that's where most of our inputs were in that, let's say, factory. And then over here we've got one that has a whole bunch of outputs, and over here we've got one that's really good at analog. So we can put those there, and then instead of wiring 50 wires real far, we can just wire to those individual components, and then have them communicate with each other as one. Okay, so imagine we've got a PLC over here on this machine, we've got a PLC over here on this machine, but we need those two machines to work together. We can do that through a distributed network. For the end of this video, I'm at 8 minutes. I tried real hard to keep it under 10, but I just want to give you a brief overview and let you see what a PLC actually looked like. Basically, a PLC is a computer that you can control big, dangerous things with. Okay, so see you later.